All right, so these are the same as the equations that we just did, except instead of an equal sign, what have we got instead? What do you notice these have instead of equals? Yeah, like a, you know, those little alligator apps, like greater than, less than, or greater than or equal to, less than, equal to. You're going to start it the same way. If you see a squared, which you are going to have, it's evacuate, evacuate, move it all over onto one side so that you have 0. So we're going to subtract over the 3. And then we want to factor that. So how is 2x squared going to split? 2x and 1x. 3 is going to have to be 1 and 3. Let's see. I think we want the 1 here and the 3 here. Let me see if I'm right. What would the outsides give us? 6. We would want positive 6 and then minus 1. 6 minus 1 would give you 5. If you try it the other way around with the 1 and the 3, you actually still get 5, but the symbols won't work out. You need 1 negative and 1 positive in order to end up with a negative 3. All right, so then what we're going to do with these, instead of setting them equal to 0, we're going to make number lines out of them. So you want to take your 2x minus 1 off to the side, draw a little line next to it. X plus 3, draw a little line next to it. When you get a lot of factors and you draw the lines, it ends up looking to me like a musical staff. Do you know what I mean? All the lines in. Now you're going to put the zeros on there, and you want it to go in order, left to right. So let's look at where these would be 0. Where would this one be 0? If you set 2x minus 1 equal to 0, like what would you get? That'd be 1/2. And what would this one give you? All right, so I'm going to put negative 3 here and 1/2 here. Do you see how I made it go left to right? Like negative 3 comes before positive 1/2. Like you want to read it. They're number lines, so it has to go in order. And then we're going to put in positives and negatives where they belong. Give me a number smaller than 1/2. Good. You want to pick 0 if that's an option, right? If you plug 0 in for x right here, you would get 0 minus 1, which would be negative 1. So this side is going to be negative. So I'm going to put in negatives up until that 1/2. Give me a number bigger than 1/2. 1, 2, a million. It actually doesn't matter. Let's go with 1. You want to keep it simple, right? You plug in 1 here. 2 times 1 is 2. 2 minus 1 is 1, which is a positive number. So you got a positive result. I'm going to put pluses on that side for my number line. We're going to do the same thing here. Give me a number smaller than negative 3. Let's negative 4. If you plug in negative 4 for x, negative 4 plus 3 would be negative 1. That would be negative. I put negatives on that part of my number line. And then give me a number bigger than negative 3. 0. Good. I'm glad you guys are getting that. Like 0. Pick 0 if you can. 0 plus 3 is 3, which is positive. Do you remember that little worksheet where where I said pick a number that lives here and we tested if it was above sea level or below sea level? That's what we're doing. We're just making a number line out of it. Okay. Is it positive or is it negative? Now I talked you through picking test numbers for those, and you can always do that. But if nothing weird has happened and you're like, well, what would happen if something was weird? You would go, oh, that was weird. Like something would be backwards, or you'd have a squared or a negative. If something was real strange, this might not apply. But if nothing weird has happened, they're going to be negative and then turn positive. Negative and then turn positive. Does that make sense? Like, but you can always pick a test number. I'm going to use a different color for this. You don't have to, but I think sometimes it helps. We're going to slice our number line into these 3 sections. So we've got everything to the left of negative 3, everything in between negative 3.5, and everything above or to the right of 1/2. So we just like sliced our number line into those 3 sections. And we're going to look at what the overall sign is. So hey guys, look at this first section. You have a negative times a negative. What would a negative times a negative be? Positive. So that overall sign would be positive. That part of the graph would be above sea level. It would be above the x-axis. This middle section, we have negative times a positive, which would be negative, good. And then this section, we have positive times positive, which would obviously be positive, okay? What section is your answer? It comes back to the original problem here. We want where this is greater than 0. So do we want the positive sections or the negative sections? We want the positive sections, which are these two. And do we want a bracket or do we want a parenthesis? Why parenthesis? Because that's right. Yeah, it doesn't have the like little equal to bar. So we want these two sections and we want parentheses. So we want -infinity to -3 union 1/2 to infinity. If it had said less than, we would want the negative sections. So it comes back to whatever the problem said, like which section constitutes your answer. Let's try it again. Someone's music is too loud because I can hear it. Can you turn that down? We're off. All right, so this one, we have it with 0 on one side. You can't factor this because it's to the third. So I'm going to need to do a synthetic division, and I'll type it in the calculator so that we can look at it. You guys can just follow along and watch me. All right, so I'm going to go to y equals, type that in. Did I type all that right? Didn't make a mistake. Zoom 6, we want to find where it touches the x-axis. And you want to pick where it's a nice whole number. So do you see a place where this touches the x-axis where it's a nice whole number? Like this one would not be a good idea because it's in between two values. But do you see one that will work? 4, do you see 4? Okay, 4 goes in the little box. This is basically a review of finding zeros. What is your remainder going to be? Your remainder will be 0. Your countdown's in order, so just go ahead and take all those coefficients, bring down the first one. You're going to multiply, add until you get to the end. So I'm going to be quiet, let you guys do that. We'll make sure we get the same thing. Did you get 2, 5, -12? All good? Okay, so put the x's back in. And now we're going to factor that. Now, I want to make my number lines like this again. I want one factor to go here and have a number line, and I want the next factor to go here and have a number line. So I'm going to write my factors because I'm going to run out of space if I don't. I'm going to write my factors down here. How would 2x squared split? Good, 2x and 1x. And then 12, you know what? I do need to show this side to side. I'll write it up here for you. All right, and then 12. Gosh, there's a lot of choices for 12. How could you split 12? 6 and 2 or 3 and 4. All right, what do you want to try? We want to get 5 in the middle. So what do you think you want to try? 3 and 4. Where do you want the 3? In the first parenthesis or the second? First one. All right, let's see if that works. What did the outsides give us? 8x, good. And then the insides, 3x. We want positive 5 in the middle, good. So we want a positive 8 minus 3. 8 minus 3 would give you 5. So our one factor is 2x minus 3. Our next factor is x plus 4. So I just put those where they go on their number lines. There's actually a third one. What is 4? Now, if 4 is the 0, the factor would be x minus 4, good. So those are our number lines. We want to put the zeros on there. Where would this one equal 0? 3 over 2, that's 1.5. This one would be at -4. This one would be at +4. So -4 is going to go first, then 3/2, which again, that would be 1.5. And then +4. Again, they're number lines. So the numbers have to go smallest to biggest in a number line. Are any of these backwards or squared, or do you see any extra negatives? Did anything weird happen? No. So they are all going to be negative and then turn positive. If you don't trust me, which I hope you do at this point, because I'm not going to like lead you astray, you can always pick a test number. If you're just like not sure and you're like, I absolutely want to make sure, pick a number on the one side, pick a number on the other side, plug them in, just see if it comes out positive or negative. But I'm just trying to save you some work. Again, it's not being lazy, it's being efficient. Now this time your number line gets sliced up into 4 sections. I like drawing those. They look like little balloons, like with strings on. I don't know, that's what they look like to me. And so we're going to figure out what the overall sign is for these. So this first section, you have a negative times a negative times a negative. What do you think? That'd be negative. Here you have a negative times a positive times a negative. Good. 2 negatives will cancel, and then times a positive will just be positive. How about this section? Negative. Good. And then the last section, positive. Again, if nothing weird has happened, it's going to alternate like that. Now, which sections are your answer? Because now essentially you're just going to write the answer. Comes back to the problem. What does this mean? Less than or equal to 0. So we want brackets, and less than means we want the negatives. So you want these 2 sections. So we want negative infinity to negative 4, union, and then what would the other one be? From where to where? Yeah, however you want it, 1.5, 1.5. I'm going to go with the fraction 3/2, but yeah, that number until 4. And brackets, because it was an equal to. Except for the infinity, the negative infinity, you can't bracket infinity or negative infinity. All right, look what I did for the next one. For number 3, this is why I called it A, B, C, D. Do you see how they're all the exact same problem, but I just changed the inequality? It's for you to do like a compare and contrast and see how it turns out. How would we factor this? X squared plus 2x plus 1. How is that going to factor? Good, it'll be x plus 1 squared. But you're like, hey, something weird happened. There's a squared in there. Where would this equal 0? I think you said it. If you set this equal to 0, you would get -1. Good. But it's not going to be negative and then turn positive. If you square something, it is what sign all the time? It is always going to be positive. So it's plus the whole way across. So it's positive everywhere except -1, because it's 0 at -1. Does that make sense? It's neither positive nor negative because it's 0. So when this says greater than 0, it's greater than 0 everywhere except -1. Does that make sense? How do we write that we want everything except -1? Like we're kicking -1 out. Yeah, negative infinity to -1, union, -1 to infinity. It's almost like -1 is your troublemaker. In this case, I wouldn't call him a troublemaker. He wasn't causing problems. He just wasn't part of the answer. Poor -1. He just wasn't invited. Well, but I have the other options here. This one says greater than or equal to. So now what's our answer going to be? All reals, right? Now we invited -1. Now we get everyone is invited to the party. That's so cool. This one says less than. Where is it less than? Nowhere, so no solution. There is no number that will make that true. And then where is it less than or equal to? Well, it's not less than anywhere, but where is it equal to? Like, so you literally just get -1. That's a party of 1. There is one number in that, which still makes me feel bad for -1. Poor lonely -1. He's like the only answer. But he's special, right? Because he's the only one. I know. Anyway. Now these ones are fractions. You're going to do it the exact same way. for this one, I made the first one simple. It's already factored. You're going to make a number line for your x minus 3 and a number line for your x plus 1. The only difference with the fraction ones, the rational ones, is even if it says you're supposed to put brackets, you can't bracket one of the troublemakers. For example, what would make this denominator 0? Because I was picking on -1 when I did this. This, bless you, this says we should use brackets, but you can't use a bracket on -1 because do you understand what I'm saying there? Like the problem says it's equal to, but you still can't make it equal -1 because that would give you 0 denominator. All right, where is this one going to equal 0? 3, and then this one is -1. So again, make them go left to right, smallest to biggest. Did anything weird happen? Is there a squared or is anything backwards? No. So they're going to be negative and then turn positive. Again, I'm just trying to help you be efficient and save you some time and work. If you want to pick a test number, of course you can. And so you slice your number line into these 3 sections. And the color really doesn't show up there at all. I'm using purple and it just doesn't even look any different. All right, what's the overall sign for the first section? Positive, good. And then in the middle, you have a negative times a positive, so negative and then positive. So which parts are your answer? Look back at the problem. It says greater than or equal to 0. So do we want the positives or do we want the negative? We want the positives. This section will be -infinity to -1. And as I was saying, the problem says you should use a bracket, but you still cannot bracket -1 because it will make a 0 denominator. Union, and then we want 3 to infinity. Now you can bracket the 3. That's okay. You can have a 0 numerator, you just can't have a 0 denominator. Let me use that. How is this numerator going to split? We'll do one more and then I'll give you a brain break. We'll do a break here. X squared plus 10x plus 25. What will that factor into? X plus 5. Ooh, something weird happened there. X plus 5 and it's squared. Okay, so hold on. When we go to put in our pluses and minuses, it's not going to be negative and then turn positive. It's a little bit different. How does x squared minus 4 split? Perfect. Difference of squares. X plus 2, x minus 2. Again, it always feels to me like I'm drawing like a musical staff. I know it's only 3 lines. All right, so this one equals 0 at -5. And then this one would be at -2. And then this one would be at +2. So these two are like quote unquote normal. I'm going to put in negatives and then they'll turn positive. You can pick test numbers, but that's how it's going to be. Negative and then turn positive. And then what will we put the whole way across for this one? Positives, good, because it is squared. And if you square something, it is always positive. So drawing your little like balloon strings. So we sliced our number line into these 4 sections. The first section, you have a positive times a negative times a negative. What is that overall sign going to be? It'll be positive. And then it's the same for this one, right? Positive times negative would be positive. You got to be careful. This one didn't alternate because something weird happened. You had that squared in there. This section would be negative, and then all positives would be positive. So what part's your answer? Go back to the problem. This tells us we want which section? The less, so the negative part, and we would want to do brackets. Here's the negative part. So you would want it to go like, don't write this. You would want it to look like this, -2 to 2 with the brackets, but I'm going to need them both to be parentheses. Why? I know the problem says brackets, but why do I have to make them both parentheses? Oh, say that louder. There's asymptotes there. Nice. They make a 0 denominator, which means there are vertical asymptotes there. So you need to make them parentheses. You can't have a 0 denominator. They are the troublemakers. Okay, do like a 2-minute break and then we'll do the last 2 on the back. All right, so we need to factor the numerator there. So it's gonna split x and x. 4 would split 1 and 4. And what symbols would you need to get -5 in the middle? -1 and -4. All right, the reason I wrote them one on top of the other is so I could make my number lines. So the numerator splits x plus 1, x minus 4. The denominator is -x plus 3. Are you like, hey, something weird happened there? There's a negative out front. Do you get what I was saying? Like if something weird happens, you're gonna notice, you're gonna be like, hey, that was weird. So let's see where these equal 0. Where would this first one equal 0? 1, good. And then this one would be 4. And then what would this one be? If you set that equal to 0, what would x need to be? 3, good. So I like to look at all of them first because you have to make them go in order. So 1 would go first, then 3, and then 4. So the first 2 are quote unquote normal. They're going to be negative and then turn positive. I shouldn't say normal, I should say like typical. They're forwards, nothing backwards has happened. This one's going to be reversed because of the negative, but let me show you. Let's pick a test number. Give me a number smaller than 3. Let's do 0. You can't negative a 0, that would just be 0. 0 plus 3 is positive. Give me a number bigger than 3. 4. You could do 7,000. It doesn't matter. Let's do 4, though. Keep it simple, right? If you plug in 4 there, -4 plus 3 would be negative. So do you see how that one turned out backwards? It was because of the negative that was out front. So instead of being negative to positive, it was positive to negative. All right, so draw in your little like balloon strings here. We're going to slice the number line into 4 separate sections and then look at what the overall sign. All right, so for the first section, we have negative times positive. That would be what? Positive. Then this section would be negative. And then this one again, negatives cancel, so positive and then negative. So that one did alternate, which happens a lot. So which sections are your answer? Go back to the problem. This means, do we want the positives or do we want the negatives? We want the negatives, and we don't need to worry about brackets. They're just all going to be parentheses. So what's our first section? From where to where? Good, from 1 to 3, union. And then where's the other negative section? 4 to infinity, perfect. All right, this last one's going to be a little bit more work. First of all, because we don't have 0 on one side. And secondly, because we're going to need to combine those 2 fractions together. So that's why I saved this one for last. First thing that you're going to do is subtract this fraction over, because you do need to have 0 on one side. So you literally just take this whole fraction, subtract it over to the other side. Like you're just moving the whole thing over. Here's the tedious step. You have to put those 2 fractions together. So this is your common denominator, x plus 1, x minus 5. You're going to multiply them by each other. Do you remember the problem we did last time with Jack and Jill looking for the needle in the haystack? And we had a 3 and a 5, and the common denominator was 15. You just multiplied them together. That's what we're going to do here. So this one gets multiplied by the x minus 5, and this one gets multiplied by the x plus 1. You're multiplying them by each other, which is a little bit tedious, but you're going to be okay. I'm going to help you through it and you're going to be all right. So for this one, you need to distribute the 2. What's that going to give us? 2x minus 10. See, that's not hard. You just have to do it. This one, you're not distributing a 3. You are distributing a -3 through there. So if you distribute a -3, you would get -3x -3, and that is all over the common denominator. Again, the idea was you wanted to take the two fractions and mush them together to be one fraction, mush being a really like technical mathematical term. You take the two fractions, you put them together to be one fraction. We've got one more step before we can draw our number lines, and that's just to put the like terms together. So what would we have in the numerator? This would be what? Yeah, -1x, -x minus 13. Actually, I guess we can go ahead and make the number lines. The numerator would be -x minus 13. And then we'd have x minus 5, and then we'd have x plus 1. Try to save you some writing wherever possible, because I know like the problems are long. -x minus 13, gosh, what would make that 0? Be really careful because there's negatives all over the place with that. It would be -13. I know that's going to be the smallest one, so I'm going to go ahead and put that on there first. All right, and then this one would be 0 at -1, so that's the one I'm going to do next. And then this last one would be +5. Which two are like typical, like quote unquote normal? Yeah, these last two. So you can make those be negative and then turn positive. Again, just trying to save you some work. And I think that's why I'm such a stickler for like, do the work I'm asking you to do, because you know that I'm going to make it like as little as possible. Like I don't believe in busy work. So only give you what you actually have to do. This one, you can pick a test number, but this negative is going to make it opposite. So it's going to be positive and then turn negative. Again, pick a test number if you're like unsure or you don't believe me, but it's going to be backwards because of the negative. And so we sliced up our number line into these 4 sections. And what's going to be the symbol for the first section? Positive, and it's going to alternate, right? Because this next section, negative times negative times negative would be negative. Here they cancel, so positive, and then this one's negative. So which part is the answer? Go back to the problem. It says greater than 0. So which section do we want? Positives. And we don't have to worry about brackets because there's not an equal to. They're just all going to be parentheses. So we want the 2 positive sections. Okay, cool. How do I write that? How am I going to write my answer? Good. -infinity to -13 union, and then the other positive. The other positive section, -1 to 5.